In this video, we're going to transform an equation in polar form to an equation in rectangular coordinates. Suppose we have the equation r equals 6 cosine of theta, and we wish to convert this equation from polar to rectangular form. In order to do this, we need to know the following conversions. Coordinate x equals r cosine of theta. Coordinate y equals r sine of theta. And x squared plus y squared equals r squared. We'll begin by multiplying both sides of our equation by r. This gives us r squared equals 6 r cosine of theta. R cosine of theta equals x. So we'll rewrite our equation as r squared equals 6x. R squared is equivalent to x squared plus y squared. So we will rewrite our equation again to read x squared plus y squared equals 6x. Our next step is to set the equation equal to 0. We'll subtract 6x from both sides. This gives us x squared minus 6x plus y squared equals 0. This equation is looking as though it can be rewritten to show the equation of a circle. So I'm partitioning off x squared minus 6x, and my plan is to complete the square on this term. To complete the square, we need to know that the lead coefficient is a, and the coefficient of our second term is b. In this case, b is equal to -6. When we complete the square, we take our b term, divide it by 2, and square it. So in our situation, we'll take -6 divided by 2, square the whole thing. That gives us -3 squared, which is equivalent to 9. Now we'll rewrite our equation. So we have x squared minus 6x plus 9 plus y squared equals 9. We have to make sure that we add the constant 9 to both sides of the equation. The purpose of completing the square is to form what's called a perfect square trinomial. This is easily factorable. We can factor any perfect square trinomial by taking the square root of our first term. Since our first term is x squared, the square root of it is x. Taking the sign that follows, here we have a negative. Then taking our constant, taking its square root, and squaring the entire result. You can also factor using a more traditional method, such as the AC method, or trial and error. But when you have a perfect square trinomial, this is a quick and easy way to factor it. So we have x minus 3 squared plus y squared is equal to 9. Now we can see clearly that our equation reflects the equation of a circle, x minus h squared plus y minus k squared equals r squared. So we'll take our equation for our circle and set up a graph. In our equation, x minus 3 squared tells me that I'm going to move 3 places to the right. So I'll start at the origin, move right 1, 2, 3. And my second coordinate is 0, because y minus k, since we have no k term, is the same as saying y minus 0, which means we'll move neither up nor down on our y-axis. So the center of our circle is 3, 0. The radius of our circle is the square root of our r squared term, which in this case is 9. The square root of 9 equals 3, so I'll move 3 units away, all the way around. So there's our circle. And we've converted our polar equation to rectangular form. So I hope this example was helpful, and we'll see you next time.